Okay, hi everyone. Well, first of all, thanks for the invitation. My name is Alessandro Alaia and I'm the head of R&D at Optima Engineering. Today, I want to share with you my experience in a previous call of Fortissimo dated back to 2014. I will share my screen. Let me know if you can see anything. Can you see my screen?
Yes. Yes.
Okay, perfect. So I don't know if you ever heard about Optimad. I guess not, but Optimad is an SME from northern Italy. We were born as a spin-off company from Polytechnic of Torino in 2008. We started as a company for customized R&D activities in the field of scientific computing. Now we are an independent software vendor, though we still have a division for consultancy and customized R&D. In 2014, we participated to Fortissimo together with University of SouthCloud, Cineca as the HPC provider, and Automobili Lamborghini. I guess they don't need introduction. And our experiment was named South Shape Optimization under Uncertainty through HPC Cloud, and was focused on shape optimization problem for automotive. So I will quickly give you an overview of the scenario we found back then, because few years have passed. So during our R&D activities for our clients, they are both SME or large industry, we noticed that although simulation and analysis were part of routine tasks, optimization was not. And then the reason for that, I believe, was already summarized this morning in the first presentation by Tommy, is because in-house optimization is basically very cost inefficient, because you need very specialized people who are not just proficient in KI software, but they also need to have a very strong background in optimization to set up a proper, fully automated workflow for the optimization. Then they need to be expert, let me say, in IT, because optimization, especially large scale problems, require a tight coupling between CAD, KI, and optimization software. And then there is the problem of actually implementing this fully automated workflow, which is still troublesome. And then on top of that, you actually have the cost of the optimization itself, because usually optimization, at least in the automotive or aerospace industry, they require what is called the full body simulation, which are quite expensive. Few hundred hours of simulation of CPU hours if you are lucky, and you probably need hundreds, if not thousands, of those simulations to perform a complete optimization task. And then you have, of course, all the costs of your in-house computing infrastructure, and then licensing. I'm pretty sure you're all familiar with licensing from commercial software. Basically, they are either floating or not locked, but basically you need to buy a license for each computational node. So for an optimization job, which might involve several computational nodes, you might spend quite a lot of money on licensing. So if you do the math, at the end, you can see that the return of the investment, it's only guaranteed if you do standard analysis task. Otherwise, it's actually quite a high cost. And so in the end, what we noticed that almost 10% of industries, they do actually perform optimization jobs. And by the way, this is very close to the number that was reported by this morning by Tommy of 8% of users. Probably his number is more accurate because now a few years has passed since we began this process. So what we noticed in our client is that they perform pseudo optimization, which we like to call man-in-the-loop optimization, which basically is to start from an old product, based on the analysis and their know-how, they decide some improvements based on a heuristics or know-how based consideration, then perform again another loop of analysis, And then in the end, after one, maybe two iterations, they choose the most promising configuration among the ones that were tested, which clearly it's not very efficient from time and costs point of view. And also you end up with suboptimal solution, which is definitely a problem for competitiveness. So we identified as a market for our proposal, basically all the SME which don't have a strong background in optimization, or maybe they don't have a very large engineering department, so they cannot actually afford the personal cost to train people in optimization, but also large industry, because they might have HPC infrastructure in-house, but there is a lot of competition to access the infrastructure, because we don't have to forget that optimization jobs are usually peak requirements for your computing infrastructure. Basically, that means that your HPC facility are sized for analysis task, and optimization it's actually quite demanding, and so as an effect of disrupting the schedule, you have to put on pause all the other analysis jobs. So it's quite disruptive in general on the schedule of even for large industry. So overall, we estimated that then this market would be between €1.25 billion, which is worldwide, of course, which is quite significant. So we came up with this idea of basically creating a platform which would offer a completely automated workflow for the shape optimization problem, where basically all the IT related aspects were basically handled in a complete transparent way. So an end user, even an end user with small background or little background in optimization, could set up very easily an optimization job, just uploading geometries, choosing a few parameters, and that's it. The whole deployment on the HPC infrastructure would be handled by this platform, and all the software, the KI tools, would be already integrated in this platform. And interestingly, we also devised a technical solution, because as you know, during optimization job, you might want to use low fidelity models to speed up the optimization. And this is quite tricky, especially for inexperienced user, because depending on how you choose this low-fi model, you can get up with very good or horrible optimization result. So we basically employed machine learning. Back then, very few people were talking about machine learning application, basically to select this low-fi model behind the back of the final user. And so for us, HPC wasn't just a way of running several simulations in parallel, but it was also a way to train this machine learning model to do this very, very specialized and complex task. Our idea was basically that at the end user would have no amortization costs or costs related to computing infrastructure whatsoever. Our end user, Lamborghini, estimated that more or less 75% of time would be saved. And they estimated also a cost saving around 30%, which comes not just from saving money from amortization costs for the computational infrastructure, but also because the idea of the platform was to be fully automated, so they could basically allocate people from the various very tedious and laborious task of setting up computation for this man-in-the-loop optimization, and they could move these people to very high added value activities. And then, of course, we wanted to make this platform open and accessible, because we do recognize that different industrial actors, they use different KI or simulation tools, so we wanted them the choice of adding these tools, their tool of choice within this platform. For us as an independent software vendor, we saw an opportunity to scale our business, because as probably many of you know, consultancy is not very scalable as a business. And we were Back then, we were basically facing several competing ESV from the optimization side, Mod Frontier, Optimus, iChrome, from CFD, StarCCM Plus, Fluent, and from CAD point of view, SolidWorks, but of course there are many others. We also identified some weakness in our proposal, because when you put up a fully automated workflow, you completely, well, the end user lose complete control on what's happening at the smallest, let me say, smallest granular scales. Plus, back then, there was no idea of deploying this platform on hybrid clouds. And then we recognize a psychological barrier, because the idea was to sell the service as a software as a service. So basically, the end user would have paid upfront, would have paid an access token, and then would have been charged by the hour, CPU hours. And then we were scared that the user might see an immediate cash flow related to the simulation jobs, the optimization jobs that were running at that very moment, as opposed to the amortization costs from an in-house infrastructure, which are basically, they are not an immediate cash flow. So I will talk more about this more later in the impact section, because this actually, this weakness caused us a lot of troubles, but I will spend more words on that later. So at the end, what we deployed and we developed between this experiment was this platform, which had an abstraction layer where basically we implemented the whole optimization tool chain, integrating different CAE, CAD, and optimization tools. We used the multi-fidelity approach, and the technical, the interesting technical part is using machine learning to guess the low fidelity model based on the few optimization settings that the user would provide to us. And this part was developed by the SouthCloud University. So I will go very quickly through the technical details, because that's not the main focus of this presentation. If you are curious and you have questions, please ask afterwards. We run with different experiments, which are pretty common benchmarks in the optimization, shape optimization community in the automotive, like the windshield for bike, the helmet, the classical test case of the helmet for bike in order to reduce the drag force acting on the whole system. And we also performed some quite challenging simulation, like the one you see here in this slide, because this is actually a multi-objective optimization. Instead of trying of improving the aerodynamic efficiency of the front part of the car, we do actually run a multi-objective simulation, try at the same time to maximize the downforce acting on the front part of the car while minimizing at the same time the drag coefficient. And this test case is quite challenging because it requires quite a lot of computation. And then what is remarkable beyond the fact that we actually managed to produce a very nice Pareto front, where you can see all the results in the feasibility region based on the constraint that we set for this test case, is that our platform would grant us a speed up of almost 8 times with respect to a standard optimization job. And for this specific test case, the machine learning model choose a proper orthogonal decomposition method as a surrogate model, which also require to build a database of snapshots, which are then used during the optimization. And if we consider this database creation, which is quite intensive from computational point of view, we still get with this factor 8 in the speed up. And if you reuse this database, you would end up with speed up of 45 times, which is quite big. So basically, at the end, this whole optimization jobs was running almost for little more than 4 days on 320 cores at Cineca, which is absolutely compliant with the typical times even for large industry. And then, of course, we had our test case with our industrial partner. This one was about maximizing the downforce acting on the front car of a Lamborghini Aventador, which, as you know, is very important part of designing the aerodynamic design, because this car, they usually have the engine located in the back of the car, their rear traction, so it's very important to guarantee some adherence in the front part of the car. So at the end, we managed to get very interesting results. And so now is the part that probably is more interesting for you, which is what happened next. So our initial goal for this experiment was to reach a technology readiness level between 8 and 9. So basically, we wanted to be on the market short after the end of this experiment. What we managed to achieve is actually TRL around 7, so we are not still there. And the reason for that is because many of those critical aspects we identified in the very beginning of our proposal were actually, I wouldn't say quite blocking, but they were major obstacles for us. First of all, the integration between different CAD tools proved more difficult. And that's, I believe, it's due to marketing and commercial strategy of the biggest software vendor, which they usually sell suite of software. So that exchange between software within the same suite is very easy. But our industrial customer, they usually use software for complete different software vendors. So somehow this data exchange is made difficult. Then the licensing model, we couldn't manage to get an agreement with some major software vendor of licensing per hour rather than per computational node. And then, of course, we could have fallen back on open source software, which is cool. We like open source software because we Optima develop an open source library for scientific computing. The problem is that especially large industrial partners, they use their software, they validated those software on their application, they spend quite a lot of time and money to validate the software, so they are not willing to switch back to open source software, which sometimes they don't have the customer care you can pretend when you are paying for the software, and also they would force them to revalidate the entire simulation chain. Then the fully automated workflow proved to be more difficult, mostly because automatic mesh generation and because sometimes simulation software are built around completely different ideas and design paradigm. And so even if they would make easy to exchange data, sometimes the data that needs to be exchanged by the software is completely different. And then with also another barrier, which is basically each optimization problem is quite unique. Sometimes they're very challenging. So even if the users would like to have a fully automated workflow, they sometimes need to have full control. And so, of course, we could fall back on implementing different pipelines and specializing each optimization pipeline, targeting a specific application, but this is not scalable from independent software vendor because we would end up with dozens of variants of the same software with just a slight variation, which is clearly not very cost efficient. And then most importantly, we hit the psychological barrier I was talking to you before, which is basically convince an end user to spend order of 10K euros to run a full optimization job, which might seem a lot because a lot of time the main objection is that they could use their in-house computational facility for free. But this is actually a non-argument because even in-house computational facility are not for free because you have maintenance cost, amortization cost, this cost, indirect cost coming from disruption of schedule of activities. So those are kind of hidden costs that you don't see immediately, because you are not paying from your pocket that amount of money. And so you are tricked into belief that actually you are not spending anything to run those simulation jobs using your in-house computational facility, while instead it's actually the opposite. The smaller is your computational facility in-house, the more you are paying. And then, of course, for larger industry, there were the issue with data security, but this is already this concept were already mentioned this morning in the first presentation. So since we've foreseen these problems, we prepared ourselves some backup strategy from industrial point of view. So right now, even though we are not on the market as with this platform, we are still offering services with this platform, and it's actually going pretty good because we managed to create a new partnership with Nolan Group Racing, of course, Lamborghini. We create a new partnership with Rolls-Royce, not in the automotive, but the aeronautic engine division for the optimization of turbine blades. And we are also selling sort of a hybrid business model. We are selling this platform to our large industrial user. So we go there, we install this software on their computational facility. And what's actually happened and wasn't foreseen is that when we presented around the solution, one of our major competitor was actually very interested in this solution, so decided to invest some money in our company. So basically, at the end of the day, between the new stream of revenues coming from services and this private funding, we are basically keep going on developing this solution, and hopefully we want to get on the market quite soon. And that's, I believe, close my presentation. Thanks for your attention. If you have a question, please come forward. I will be happy to answer all your questions.
So thanks a lot, Alessandro. This was very
problem. Thanks for your. I'm sorry. Come again?
No, I'm just asking if there are any questions about it. So.